Yeah, okay. This looks better. Okay, we'll take this one. And now it's not even cut off. Good. So, hi, I'm Philipp. I work for Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats. You might have used or seen some of our products. Look something like this. And of course, we want to run, or probably you want to run that on Docker or Kubernetes. So what are we doing about that there? So generally, who uses containers already? That's probably everybody. Who uses containers in production? That's almost everybody. Who uses containers for stateful stuff, like databases? Relational, Kafka, anything like that? Okay, that's quite a few. Is anybody using our images? A couple? Is it really ours, or did you build your own? Ours? Okay. If you're building your own, I would be interested in why, but we can discuss that afterwards. So, what I kind of want to talk a bit about is like Docker images, like how we build them, why we build them, kind of the thoughts about those. Docker Compose, what we have around that and why we don't want to do that much more there. Quickly about Helm charts, and then our operator and how we're building our operator. So, I guess everybody is using Docker when we talk about containers, right? And not something different. There are some other technologies, but probably Docker is the most widely used one. And this, by the way, is the proper logo for Docker in most cases. And this is also what the size of your average Docker container is nowadays. Because it's not a small little fish anymore, it's more this big shark thing. Internally, we have this saying that Docker is one of the most heavily funded college projects because that's how stable it is sometimes, and the APIs often keep breaking in a weird way. So we're sometimes not so happy with Docker, but since everybody uses it, we have to do that as well. Generally, for us, we see Docker a bit like the new zip format. Like, it's the ubiquitous format everybody wants to have, everybody wants to use that as well, and it's just one other way to distribute our software. For us, Docker is not really special in any way, it's just one distribution format amongst many. So we still have all the others, like you can use any of these methods, and we don't have a strong opinion on which one you should use. Whatever makes most sense for you is the thing that you should be using. We don't say like, please use Docker because it's the right way. We don't really care, whatever makes sense for your architecture. It is, though, not without issues. And I want to quickly show some of the things that can break or are going weirdly, maybe. So one of the things that we see every now and then is that people try to run stuff as root in Docker containers. Is anybody running a lot of stuff as root in Docker containers or wants to do that? Is it something that you can do optionally, or do you really want to run it as root? It's legacy, okay. It's the easy approach, right. So one problem that we have with that is that, for example, Elasticsearch cannot run as root. Because basically when the process starts up, we use JNA, the Java Native Access. We check for the capabilities. If you have root permissions, the process will system exit. There is no way to run Elasticsearch as root. What you would need to do is you would need to fork the source code and comment out the system exit. Otherwise, there is no way to run it as root. So there is no way around that. And generally, this often looks something like this, that you can replace the snake nowadays with a whale, the Docker whale, that this one is saying, like, run everything as root and don't care about permissions anymore. This is what we see quite frequently, that people say, like, we don't care about permissions, we don't care about root or not root, we just want to run our software. But it doesn't really work like that. I call this one of the cockroaches. It's the things where we agreed quite a long time ago that you shouldn't run server processes as root. And now the idea kind of came back because people say like, oh, we put it in a Docker container, it's just inside the Docker container, so I don't care anymore as what it runs. We don't really agree, but this is one of the things that keeps coming back again and again. The other thing is that the data directory for Elasticsearch needs to use a specific user, the Elasticsearch user, with a user and group ID of 1000. If you have that from another container or you manually created or changed something, those permissions might be wrong, and then the container cannot start up correctly. And people were very unhappy about that because before, Docker Inc. was providing an Elasticsearch container as well, and that one would mutate the permissions in a way whatever it needed. So that was kind of annoying. And the problem then is that a lot of people start opening issues and say like there is a bug, and they say something like, I prefer a simple fire and forget Docker container. And for us, this is pretty much an anti-pattern that you don't want to have. Because whenever somebody writes something like this, what we imagine that somebody does is something like this. Is that you don't really care what you're doing with your data, and that's not the way we want to handle your production data, because the way we build images is mostly for production. So it's not the YOLO approach, you just throw something in, you don't care about permissions, you want to do the right thing. So we kind of fundamentally disagree on that one. The other thing is we don't mutate anything on the bind mount. So obviously you don't write your data inside the Docker container, because if you upgrade the version it would be gone. So you have a bind mounted folder where you write your data, but the permissions on that one also need to be correct. And what we often see is that those who don't remember how Unix permissions were working suddenly are back in that. Even though everybody thinks, well, Docker containers abstract everything away and you don't really need to know anything about Unix anymore, that's not really true, especially about permissions, but also networking. It's coming back to you every now and then, and there's no way around that. So you will be back at that one. Is anybody using latest for external dependencies? Okay, now nobody tries to dare to raise their hand. Does anybody know, do we support latest on our images, for example? Has anybody tried that? No, we don't. This is one of the ideas I call the zombies. The things that should have been killed by evidence a long time ago, but keep shambling along. For example, in Maven, there is no latest, or in Gradle. And we kind of agreed for external dependencies, you shouldn't have latest. You should always pin to a specific version. And that was a lesson that people learned over many years. And maybe you can define a range for your dependencies, but you cannot just say, whatever is the latest version, give me the latest version. And that was agreed that is this the right approach. And with Docker, suddenly we're back at that where people say like, yeah, give me whatever, I don't care, just whatever latest. So we don't have that. And one of the big problems there is also that if you go to Docker Hub and you look at the version that you can copy, basically here you can copy and paste this image, Docker pull Elasticsearch, and this will not work because we don't have latest. And there's unfortunately no way on Docker Hub to actually specify a version there. What we would love to have is that there is the latest version in the thing that you copy there, and that you would copy the right thing. And then people always copy this and then say, it doesn't work. And we're like, yes, it doesn't work because you need to specify the version, and this is a good practice, and you should do that. You shouldn't do whatever Docker Hub is trying to promote here, because this is not a good idea. So that's a bit of a pain point from Docker Hub then. Does anybody know, do we support something like this? Because maybe you could specify the major version, because what is the danger of having latest, especially with data? That you spin up a 3-node cluster today with, let's say, 7.4, and in half a year, you add 2 more nodes because you need more capacity. And then we might be at the next major version 8, and they might have some breaking changes, and then your cluster might break in a weird and unexpected way. So that is what we try to avoid. Could you maybe fix that by saying, oh, we specify, or we are stuck on 7, like, give me whatever is the latest version in 7, or even 7.4, and just give me the latest patch version of 7.4. Are we doing that? No, we are not doing that either. You really need to specify the exact version. Why are we not doing version ranges? Because Elasticsearch is based on Apache Lucene, and Lucene can sometimes be a bit picky. Once it has written data with a specific Lucene version, it can read that from an older version, but an older version cannot write on top of a newer version, basically. And that creates problems that if you have newer nodes and you then migrate some data to older nodes, that they might not be able to write that data anymore. And your cluster might get imbalanced because of that. So you want to avoid that with the way we write data. So we don't support that. By the way, what's in a tag? You can see something like that here. All of those are pretty old, but 5.3.3, for example, 2 of those were released 5 months ago, and 1 was released 4 months ago. And by now it would be probably 2 years and 5 months or so ago. They're all sorry, the same version, though 2 of them are older than the other one. What did we do here? And we did something that is not a very good practice, but there is no good way around that. Basically, we were overwriting the tag because we had a bug in the Docker image. So the Elasticsearch release itself was fine, but the tag had, or the Docker image had a problem. So right now, if we have a bug in Docker, we will have to overwrite the tag unless we have a release soon afterwards to replace the entire thing. But the Docker image is not version itself. It's only the Elastic Stack version basically playing into that version. But we have a lot of meta information about what is built in there. For example, you always have a, probably that's very hard to read, but you have a schema version ref, and there is the git hash in there. So these you can always use to check what you actually got in build. The other thing that we kind of have as a problem now is what happens if you have a security issue in your base image or in the JVM, and you released some version half a year ago. You will probably have some security bugs in there. Do we re-release those old images with newer secured and fixed ones? No. By now, we treat our images as immutable, so we create one version once it's released, and the idea is that you always upgrade to a newer version of our software, but also of the base image and the JVM. So there's only one way, and that is normally forward and not replacing existing images. Will we add few or multiple images in the future? Maybe, or most likely actually, because what happened is that our images got quite large and people were not happy about that. One thing though that we do definitely try to avoid is any runtime mutation. Does anybody do runtime mutation? Like you start up your Docker image and then you install something or you change something on the Docker image and then you actually use it? Hopefully not, because we are also very much against that. So what people often want to have is, I provide a shell script, like I bind mount the shell script, I run the shell script, and then you can use the Docker image. Or you provide some environment variable and dependencies will be installed because of that. We don't like that, and we don't want to support, we're not supporting that. Why are we not supporting that? Because there's always the danger that this works on 3 images, but on the 4th image or so, the internet connection is not there, and suddenly you have a different base image than the others. So images are always, or should be, immutable. Like you build them once, you run them, and they're all the same everywhere. And you cannot have differences in the image, because otherwise you will run into weird bugs, especially if you install plugins on some images and not on others. Your data will be in a weird state, so don't do that. How to properly do that is, you have a regular Docker file, you customize that, like I install some plugin here and I install some other plugin here. You build another image, you push your custom image to your own registry or to Docker Hub, and then you use your own image. So you have the same image everywhere, and that's the proper Docker way to do stuff. For example, if you want to have a key store where you keep some secrets obfuscated, how you would do that is you could just do a Docker run to start the container, like an ephemeral one where you SSH into that one, or basically you run a bin bash in that one, you create the key store, and then you can mount that afterwards. So you never need to bake in your secrets. Is anybody baking in SSL certificates or secrets into their images? Anybody? No? 1, 2? Okay. This is also something we try to avoid, because for us the image and certificates and secrets have different life cycles. Like you have an image and you might need to rotate this SSL certificate because it's running out, but you don't want to replace the Docker image. You might just want to replace the certificate but not the rest of the image. Or you might want to rotate the password today. At the same time also, when you upgrade images, you probably don't want to roll up all your passwords or reinstantiate them. So for us, TLS certificates and credentials have a different life cycle than Docker images, so we try to keep them separate. And you keep them either in a bind-mounted file or in a configuration file. So here, for example, I would generate my key store, and then here, this is a Docker Compose example, but pretty much the same anywhere, and then you just mount the key store. So you don't bake in the key store into your images, because they just have different life cycles. Base images. Who cares strongly about base images? 1, 2, 3. Okay, what is everybody using? Something like Alpine, Ubuntu, Debian, something like that? Red Hat, CentOS. Okay, it's a wild mix. So we started off with Alpine images and Ubuntu images, a mix, but we ran into too many bugs with Alpine, because MuCL is nice and new, but not as battle tested as glibc. glibc might be old and nobody likes it, but it has been tested on pretty much any system and with any stuff you throw at it. So for us, it proved just to be more stable in the long run. And that's why we went with CentOS. Also because our largest user base basically is in the US, and they like anything Red Hat based. So for us, CentOS was the logical choice for that one. The good thing is, all of our images share the same layers, so you only have a thicker or bigger base layer, but since all our images share them, it's only there once, and it's kind of a similar setup if you have all the same images there. And the other thing is, yes, our images are larger, but as soon as you have the JVM on your images will not be super tiny anyway. So even if you have a 20 megabyte image, if you have the JDK, you probably have at least another 100 megabyte for the JDK, so there is no way around that. And like I said, glibc is kind of the thing that turned out to be not so nice, but well tested. The big downside is size. Our images are much bigger because of that. So I once put that together. For example, you can see this is like recent images. I put that into a table that's maybe easier to see. So you can see this one here, for example, this was Alpine. So this was a lot smaller, but we also added a lot of features over time. So this is why this keeps growing. And you can see, for example, Kibana almost, doubled in size as well, even though that was based on Ubuntu. So our images are not super small right now. We'll probably have smaller images soon as well, just because they will have some advantages as well. Who is very concerned with the size of images? Okay, interesting. The question is also a bit why. Because for us, or one way to think about that for us is, Elasticsearch, for example, you probably have data in there, like 100 gigabytes of data. Do you care much about an 800 megabyte base image if you have 800 megabyte, if you have 100 gigabytes of data there? Because that's in comparison relatively small. Also, Elasticsearch you will not deploy on a daily basis. Like if you have a small stateless application and you deploy that 20 times a day, I also get that you want to have small deployment units. But Elasticsearch is nothing you want to deploy 20 times a day. We only release every couple of weeks, basically. The only place where I can understand it is for your development machines, because you don't want to have so much disk space wasted on development machines. But since we share all the layers, our hope is that this is okay, and maybe you have some other CentOS 7 based images as well. So we are not super concerned about the size in general. I know some people care more about security issues. That might be another thing with bigger or smaller images. Though the way we check our images, most of the stuff that is in there is not really exploitable, to be honest. Okay, like I said, if you have stateful stuff where you have a lot of data, the image size is probably less important. Also, you cannot dynamically move images around that easily because, yes, the image is bigger, but 800 megabytes is very small in compared to 100 gigabytes or a terabyte of data that you have in that image, actually. And that's the part that makes it slower to move around and not the image size. So we don't care so much about the actual image. Maybe we'll have multiple images in the future, like I said. Is anybody looking for Windows-based images? Okay, this is what I was expecting. But people ask that like once a quarter or so, somebody asks us like, will you provide Windows-based images? Because one thing that is an advantage for Windows-based images, if you're on more recent Windows Server versions, you can skip the VM layer in between. Then you can basically run Windows containers natively on Windows without the small VM layer in between, which might have a performance improvement. Okay. What is that? That is the Compose logo, like the keeping stuff running. Who is using Docker Compose? I guess a lot. Is anybody using it for production or anything other than local development? Okay. On single hosts or spread over multiple nodes? On one single machine or over multiple machines? On a couple? Okay. So what we generally see is that Docker Compose is very nice, especially for local development or demos to bring up something quickly without much complexity or overhead. But for production, normally we don't see that much, to be honest. So the minimal file that might also be not super easy to read, but what you get here is you have one Elasticsearch image, one Kibana image. This is pretty much the minimal example to bring up Elasticsearch and Kibana with Docker Compose. The two will talk to each other. You have bind mounted the data folder, and that's pretty much it. That will just work. It's great for development or testing and demos, but probably you don't want to run that in production. So that's what we have. We have another demo repository where you can basically see everything in one repository. We're still not sure if we want to keep maintaining that because everybody seems to move away from Docker Compose in the long run. We'll see. Okay, so Kubernetes. Who is using Kubernetes? Okay, quite a few. I'm also always interested is anybody still using Swarm? Or has ever? No. One, or do you want to continue using that, or are you more on the way out? Okay. So yeah, let's see what the future about that one is. Is anybody using something like Nomad? HashiCorp is pushing that. Okay. Mesos. 1, 2, 3. That's also there to stay, or that's more to move away? You've moved from Nomad to Kubernetes, okay. Yeah, so the big thing we generally see is all of those things around and you have a few people using that, but in the end, the trend is very much to Kubernetes. So for us, it's pretty much Kubernetes only and the others like, I know that a couple of people built with Docker Swarm something based on our images to run Elasticsearch on Docker Swarm, but we never officially supported that because it felt a bit like a dead end, to be honest. Okay. So how do you run stuff on Kubernetes? Basically, static configuration to deploy resources to Kubernetes, and what you get with that is something like this. So I guess most of you have seen that. You have the master node with the API server that keeps track of what is going on. You have kubectl or kubectl, however you want to pronounce that, talking to the API server, and that will then make sure that your kubelets actually run whatever you want on your nodes. So this is the base architecture that everybody knows from Kubernetes. What you get with that as well is this, and lots of it. And then the question is always like, who likes YAML? I was already bashing YAML a bit yesterday in a short talk. I don't want to bash you too much now. Those who have been there yesterday will remember this one. What is going wrong here? That is actually an example from the Docker documentation. If you run that through a linter, what you will get is that this one here will turn into some weird number, because this here means base 60 then, like any number with colon and lower than 60 will be interpreted as base, and that's why you get this weird number out of that. And that's why your port mapping there breaks. So the solution for that is obviously quote, like everything below 60 quote definitely, and this one quote maybe as well, and then it will be interpreted correctly by Docker. So this is one of the joys of YAML and why you maybe don't want to write all of that yourself. So the one thing we had with YAML, or with Kubernetes actually, was that before 1.8, there were no dots in environment variables allowed in Kubernetes. For no good reason, because dots are totally legal environment variables, and unfortunately for us, those are an important way to configure Elasticsearch things. Like, we always use dots in environment variables to configure stuff in Elasticsearch. So before 1.8, you couldn't really use our images with Kubernetes. Since then, it's generally possible, and you can build whatever you want with that. And then there is Helm. Is anybody using Helm? A couple, okay. Helm is basically a package manager. So you have templating and a bit more complex resources. What you basically have is you build on the existing primitives you have with Kubernetes, but you just have some templates you can use. So you don't have to set up everything yourself. You just have a template that you fill in, and then the Helm chart will deploy that in the right way. Or it can also do an upgrade for you. So we do have Helm charts on that. Those are still better, and they support Elasticsearch, Kibana, FileBeat, and MetricBeat. So those components you can just roll out with Helm charts. And it's pretty simple. It looks something like this. It's based on stateful sets. So you have the data in a stateful set on a node, which then supports a rolling upgrade. So the stateful set is not bound to the lifecycle of one pod, but it stays there. So you can then just reuse when you replace the image, it will just reattach the data, and you can do a rolling upgrade easily. And basically, when you do an upgrade, for example, we would replace one node, wait for the cluster to be green again, then go to the next node, and then reattach the stateful sets as we go along throughout the cluster. That's pretty simple. It's only currently tested on Google Kubernetes Engine, but we have, so this is where the tests run nightly, but it does support many other environments, like from Minikube to other managed Kubernetes services where this runs. The thing that is important about Helm charts and our approach for Helm charts is that they're unopinionated. So they don't bring in a lot of operational knowledge that we have with Elasticsearch. They pretty much give you images and an easy way to use the images with the kind of like things that we bring with them. So we use environment variables to set up stuff. You can just mount secrets, you can reference SSL certificates, but we don't set up anything for you. So we don't generate SSL certificates, we don't generate secrets for you. Those you just need to provide yourself and then use them just with any other Docker image. So there is no operational best practice built in. It's just how to deploy this in the regular Docker image way. And it could look something like this. So if you run that on Minikube, this is a Minikube example, you just do Helm repo, add Elastic, and then our Helm chart. You say which version you want. By default, you would get the latest tag, which is this one. Then you need to add some storage classes to run it on Minikube. And what you then do is you have a make file, and in a make file that would run this one here. The only thing I think that is important to say is that to set affinity soft, because normally we would try to not co-locate the same data on the same node for resiliency. But with Minikube, everything runs on localhost for you, so we don't want, or we need to have the soft affinity. And otherwise, you just give it some resources and set up what you want to have. And you have a claim for the disk, and you can set some resources, and that's pretty much it. And then you will just get a node running like this. And then you have operators. Who is using Kubernetes operators? That's far fewer. Okay. So operators are going a bit beyond the primitives that Kubernetes is giving you. And the idea is that you have applications that you can manage and customize. So you basically tie into the Kubernetes interfaces and extend those. And how you need to think about that is you get a custom resource definition, a CRD. That term will come up a couple of times afterwards, custom resource definition, CRD. Now, basically, you're not thinking in the built-in Kubernetes resources anymore, like services, stateful sets, etc. But now you're thinking in Elasticsearch, Kibana, APM, whatever. So now you're thinking more in application level things and not in Kubernetes primitives anymore. So the operator framework is basically abstracting those away and gives you these custom resources, which is more like the thing that you're interested in and not how the low-level plumbing works anymore. That's the general idea here. And basically, you have a custom controller that brings the resource definition, so you provide a definition of this is what I want to have. And the custom controller brings that to life. And that to life has, the important thing here is especially the reconciliation loop. So basically, this controller runs continuously and continuously checks what have you defined in a CRD, what do you have, do I need to make any changes? This will also figure out, oh, you have configured, you have three instances of Elasticsearch, but one node with those died, then it will bring up another node for you, and it will continuously do that. Whereas Helm as a package manager is basically doing an operation that you tell it to do. So in Helm you say like, install Elasticsearch, upgrade Elasticsearch. It's basically a one-time operation that you run. Whereas an operator is continuously checking, this is the current configuration, this is where I am. And then it moves you or it keeps you in that state, whatever is configured. And it continuously does that. And this one also has best practices built in. So basically this knows how to do an upgrade or how to do a scaling operation or scale up or scale down. So here the operational knowledge is also built in. And there was a pretty widely used operator by somebody called Pires, but they gave up maintaining it after 3 years. And that's when we basically thought, well, this is our chance to take over. So this is the logo for this one. That's the Elastic operator then. This is beta. It has reached beta, I think, 2 weeks ago or so. This one provides Elasticsearch, Kibana, and APM server. And is, unfortunately, it's not called operator. We call it Cloud on Kubernetes. But this is the right repository. So if you search for operator, you will not find it. It's called Cloud on Kubernetes. Naming is unfortunately hard. Does this give you the same things to run as the Helm chart? No. because the Helm chart gave you file beat and metric beat, but no APM server. So what the operator basically does is, the way we see it is, this one gives you the server components. So Elasticsearch is centrally run, Kibana is centrally run, and the APM server as well. To roll out other resources like metric beat and file beat, you could still use the Helm chart to deploy those. And you don't continuously need to check in what state they are. Basically, you would roll them out once and then run them, for example, the beats as a daemon set somewhere. The components we build our operator on, so an operator is actually written in code and not just in YAML anymore. So this is running on Golang. We're using KubeBuilder 2 as the framework behind it. That's basically the SDK that ties into the Kubernetes APIs to create those custom resource definitions. So this is what this is built on. And then we also use Kustomize to build specific flavors. So for example, if you're using some very old Kubernetes version, I think below 1.12 or so, then we might have to do some customization that is actually working there. And that's what we do with Kustomize. So those are the main components behind our operator to build those. And unlike the Helm chart, this one is very, or not, maybe not very, but this one is opinionated. So it does encode best practices and operational knowledge. So it knows how to do stuff the right way. So it will create certificates, it can replace certificates, it can scale up and down, and it does that in a way that we think is the right approach to actually run that on our images. So for example, if you scale down, rather than just killing a node, it will say, okay, I know I want to remove this node, then it will drain the node. So it will make sure the data is migrated off the node before it actually takes out the node, so that you don't have any capacity issues or you don't have the right number of copies of the data that you want to have. During an upgrade, for example, it knows to do an upgrade. What we normally want to do is we want to disable shard allocation. Shard allocation is basically a node goes away because it's being upgraded, and then the other nodes should not replicate the data because a copy is missing now, but they should basically wait until the node comes back into the cluster. So you don't copy data around unnecessarily. So this kind of knowledge how to do that, scaling up and down or upgrading, is built into the cluster. And that's done automatically for you. But it doesn't avoid shooting yourself into your own foot entirely. So for example, if you configure 0 replicas, so you have exactly 1 copy of your data, and you upgrade a node, then that 1 copy that you have might be on a node that is currently being updated, and then the data might not be available as long as the process takes to upgrade to the next, or 1 node to the next version. So it's not foolproof, but we try to kind of help you bring the right things into that mix. To run that on Minikube, this is, by the way, the reason why I'm not demoing that on my laptop, because that's as much memory as I have. This is what we saw that works well in any demos. If you have fewer resources, the stuff might never start up. So if you just give it 2 or 3 gigabytes of memory, probably you will not get anywhere. And it's not your fault, it's just the resource lag that you have. So it goes a bit wild on that one. What you can then do is you just download we have multiple ones, but we have the all-in-one. This gives you everything in one place. So you apply that operator. With that command here, you can monitor what is going on. And then you can just apply that specific configuration. And that APM Elasticsearch Kibana file, this is spread out over the next 3 slides. So the next 3 slides will show you how the template would look like to actually run that. And this is what you do with Elasticsearch. So you can see it's our operator. So we have our only API version there. It's a beta 1 right now. Previously we had an alpha. Soon we will hopefully have a stable version. Then you just specify, okay, this is the version. These are the resource limits. This is the volume claim where you keep your data stored. And that's pretty much all you need. Kibana and APM are much simpler. So for example, for APM server, this is all you need. It doesn't have any stateful data. Basically you say, okay, this is the reference where you can reference Elasticsearch on which it depends. This is the version. This is the API version. That's pretty much it. Kibana just looks exactly the same. Since there is no data and we don't really resource limit those, that is what you have. Those are very simple. And then you can just check the status. To expose Kibana, for example, you would need to forward the port, and the operator automatically creates credentials for you. so you can just reuse them and don't specify them up front. And this is how you would fetch them. So basically, so from our Elasticsearch example, Elasticsearch user, we would need to parse the JSON, and then in data elastic, there is where the password is actually stored by default. So when you spin up an instance with the operator, it will create credentials for you, and there is always security enabled. There is no way around security. And this is how to retrieve the password, by the way. In the latest version with the operator, for HTTP access from the outside world, we always enforce TLS certificates. Inside the Elasticsearch cluster, between the nodes, you can turn off TLS now so that you can run it behind Istio if you want to. So if you have a service mesh and want to have the Istio sidecar in front of it, we do support it now so that you can turn off TLS there, and it works for that one. Yeah, if you change anything in your configuration, all you need to do is you change whatever you want there, and then you apply that configuration, and the reconciliation loop will then roll that out for you. This is what the general reconciliation loop looks like. So you have up there, this is the resource definition, the CRD that you have put with kubectl put into your cluster. And then you provide your configuration. So top there is basically the operator. And then here, this is the configuration that you provide. And then your operator will continuously check like what is configured here, what is in Elasticsearch and Kibana running there. If the two are not in or if those are not in the state that you have defined here, it will apply the changes, and it will just continuously run those operations and bring your cluster into that state. And that is really the idea of an operator. So you have this reconciliation loop that brings your cluster into the state that you have configured and keeps doing that continuously. This one is pretty widely tested and supported. Data is also based or built on stateful sets, because people always ask, like, where do we keep the data? And that just reuses the volumes when we do a rolling upgrade. And it's pretty much the standard way of doing anything in Kubernetes nowadays. So we can reattach volumes, we can do upgrades, all of that works seamlessly. Generally, we have by default persistent volumes, and that is what we would use. So either local persistent volumes, or if your cloud provider has something like Amazon has EBS, the Elastic Block Storage, or whatever your cloud provider has, you can just use those as well as your persistent volumes. You could also use something called emptydir or host path. This is basically just local data, and if the node dies, the data is gone. That is mostly for demos, or if you have data that is easily recreated or just more or less a cache or something like that, then you can use that, but it's not durable, quotas might not be enforced, and you could over-allocate, and then it might get evicted. So those have some trade-offs. So they're simpler, but probably don't use them for any relevant data. In the future, we might extend that with our own implementation for better local persistent volumes. So there is a general interface you could implement, or there is stuff like OpenEBS, which is another project which provides a generalized data backend for stateful sets. And we might officially support those. I have seen blog posts that is actually already supported, and you can just plug that in if you have OpenEBS running. One thing that you need to keep in mind are always permissions here. So CRDs need admin level permissions to install, and the container right now needs privileges, because what we do is we set something like max map count on the host, and that needs to be set on the host, which is not really a best practice, and we probably will remove this, and then you will need to set it up correctly. So you will need to set up something like max map count correctly on the host to run our containers. Right now we fixed it for you, but it's not so nice that our containers change something on the host. It's not really a good practice, and we should get rid of that again. But you will still need admin level privileges. And then there are two deployment ways of running an operator in general, and we support both as well. You can have a global namespace, so we have Elastic System. This is the example namespace that I use for the operator. And then you have in all your other namespaces, you have your actual clusters running. This has the advantage that you only have a single operator running, and you can reuse that, and also that this namespace is separate from this one, so you normally don't accidentally delete anything in here because it's a different namespace and you don't connect to that one. That's kind of like the protection, because whatever you screw up in your own namespace, it won't affect the operator. that's kind of a nicer separation for that. On the other hand, then the operator only can run in a single version and everybody has to share that one, and it needs global privileges pretty much, which is the downside. The other approach is that you have a single namespace and basically you run the operator in your namespace with your data. And then you could have that run independently, independent versions by independent teams, and they can do whatever they want. And then you can also limit the privileges of the operator to that specific namespace. Otherwise, in the previous example with the global one, our operator would basically manage all the namespaces in your Kubernetes cluster, which you might not want because you might have 10 other namespaces which don't have any Elastic resources, and the operator would still monitor those namespaces. So it's a bit of a trade-off what is easier for you to run. This will, of course, also need slightly more resources because you have the operator running multiple times. So these are basically the ways to set those up. There are plenty of other operators, by the way. So there is Operator Hub run by Red Hat, I think, and there you can get all kinds of operators, and they all work more or less in the same way. So Operator Hub is where you can just have a check at what other operators are there. And it seems that especially for more complex services, operators are more or less the way to go because you can build in that operational knowledge. And it's not just installing something, but rolling it out the right way. And I think we still have a couple of minutes. But to wrap up, containers are disrupting the industry. We really like this quote, but it's not always a good thing. Sometimes it's also because people screw up so much stuff with containers that they're actually disrupting your services, so we're a bit skeptical of that one. This is a question that people often ask us, can I run Elasticsearch on Docker and Kubernetes? The answer is obviously yes, but the question you should be asking instead is, should I run Elasticsearch on Docker or Kubernetes? And our answer is always, that's a bit up to you. If you don't really know much about Docker or Kubernetes, don't start with Elasticsearch, because it's not an easy, like, you basically combine two complex systems, and combining two complex systems normally gives you more despair than you would want. So if you don't know Kubernetes, don't start with that, but start with something more locally installed. Otherwise, you can do that. Right now, we have a Helm chart and the operator. Will we keep both? For now, yes, because they kind of serve different purposes. Like the Helm chart is the more standardized way without much opinions, but it has the advantage if you run 100 services, it's pretty much like a standard way to run things, and you don't need to know too much about that. Whereas the operator is much more opinionated and does stuff in a specific way, so you will need to know a bit better what it's actually doing for you to understand what is going on. So for us, those are pretty much two lanes that we'll keep in parallel running around. And with that, I think we have like 3 minutes left or so. Any questions? Has anybody tried out our operator, by the way? Not yet. Okay. Because I would have been interested in feedback as well. Or I guess nobody has tried the Helm chart either. Okay, then no feedback. Any questions? Yes. Do we have a microphone, or should I repeat? Because I'm not sure I will actually understand you. Or also the recording will not have you. No? Okay, I'll repeat the question. Ah, perfect. Thank you.
Hello? Yes? You talked about securing the Docker image with by not running it as root and using all sorts of approaches. But if you take a step back and look at your base image, which is CentOS, if I understand correctly, how do you know it's secure? Because in our organization, we do not trust any outside image.
Right.
So we cannot simply use CentOS, Ubuntu, or Pine, for that matter. We need to either procure a hardened image from a trusted authority, or we should build it our own and apply, for example, CIS benchmarks for that. So,
yeah,
what is Elastic position on delivering a secure image that is based on?
Yeah, so I mean Let's see if that one will work or not. By the way, to build our images, this moved to the Elastic repository. So if you go to github.com Elasticsearch, there will, I think it's a folder called deploy or something like that, where you can see how we actually built the image. So our recommendation is, if you need to build your own custom images for security reasons, look at how we built the image and then just replicate whatever we are doing to do that on your own base images. Though, to be honest, I think that's kind of like, how far down do you go the road of who do you trust? Because the next step then is like, do you trust any binaries that you get, or do you compile everything from source? And then the question is, do you trust the source? And like, how far do you go into that chain of who you trust?
Yep, that's also a good remark. But in order to, for the community to, for enterprise community to be able to easily reuse images or any other packaged software, we have to be sure that it's been packaged with the security in mind in the first place. So,
I mean, you can see how we build the images.
Yes.
And if you don't trust us, you can run it yourself and build your own images.
It would be nice to get it out of the box, because otherwise we have to do all the hardening for CentOS ourselves. So do you see the dilemma here that enterprise customers cannot simply use this as is?
Probably not. Like, I know a couple of places that require building their own images, but how we do them, it's open source. You can see, you will just take that and build them in a similar way then, I guess. That's the only way for that. I think we're pretty much out of questions. If you have more questions, just find me afterwards. If you want stickers, we have stickers here. Take all kinds of stickers, and thanks a lot.